Okay, so today we're doing similar triangles. So before, when we did congruent triangles, that meant they were exactly the same. When you have similar triangles, it's like they've been enlarged all by the same amount, yeah? So if you have, it's like you've done an enlargement of it or you've done a reduction of it, but they're similar because they're the same dimensions as such. So if you see here, they're saying that if you say the two triangles are similar, we see this symbol instead. So that was the similar symbol. And if you remember that this one was the congruent symbol. So if we have a look, there's ways of knowing whether they are similar or not. So the first way you can tell, so the first rule there is if all the angles are the same. So if you're given 2, you might have to work out the other one, but what should the angles in a triangle add up to? 180. Good. So you can test. So if all 3 angles are the same, you can say that the triangle is similar. So another way we can say is if the sides have all been blown up or reduced by the same amount. So if you have a look, can you see that 1, I've times that by 2 and I get 2, don't I? Now if I times 2 by 2, what do I get? 4. Can you see how that's what that one is? And then if I times by 2, what do I get? 6. So because they've all been blown up by the same amount, you can say that they are similar. And when you see how I said they've all been enlarged by that 2? They call that 2, that's the scale factor. It means what they've been multiplied by. So this one has a scale factor of 2 because it got multiplied by 2. So then you've got, so that's another way we can say, and we would say that all the sides are similar. So if you have 2 pairs of the sides that have been blown up the same way and the angle is the same. So the angle between these 2 sides, they're saying are the same. Now, this has been multiplied by 2. Has this been multiplied by 2? Yeah, so it's similar. So you can say there's another rule. You can say they're similar. Now, with this one, we can use the right angle triangle again, and you can just test the sides. So this is the hypotenuse, isn't it? And this 8 is the hypotenuse. So what have they done to the hypotenuse? They've times it by 2. Now, have they times this other side by 2? Yeah, so you can say that one's similar, and we've got a right angle, so they must be similar. So here down here, they said the scale factor. So the scale factor for all of these were 2, because that's what we multiplied it by. So if on the next page, we've got a couple of questions here. But I've put the solutions there for you because you get to take your reference book into the test. So we make sure we've got some. So if you get stuck, follow this example. So it said decide whether these pairs of triangles are similar, giving reason. So let's have a look at these 2. Now we've got 2 angles the same. So if 2 angles are the same, that one must be the same, mustn't it? Yeah? Because it'd be 180. So this one, we would say they're similar because of their angles. So you might say angle, 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 and you could say that they're similar. Okay, so they've put the solution down here. So you can say triangle because of AAA. All right, with B, let's have a look. Now, if I look at this 7, they times that by 2, and I could say there's 14. If I times this one by 2, what do I get? 16. It's there. And if I times that one by 2, so they've all been multiplied by the same amount. So we could say they're similar, and it's due to their sides. So that's where they're saying they're going triangle ABC is similar to triangle DEF, and it's due to this one's all the sides being the same. Okay, so let's go to the last set of ones. So let's have a look here. We've got an angle the same, and we've got the sides that are included in that angle. So if I times 2 does it look like it's the same? If I go 2 divided by 3, yeah, I get 2/3. If I do, what's the other side? 4.5 divided by 3. What do you know what you get? Do you get 2/3? Or sorry, I should say the other way around. 3 divided by 4.5. You'll see that you get, I'll see here, so they've shown you down below. We'll look at down below. So what they're doing is they're comparing, they said this 3 divided by this 2, that's here, gave 1.5. And then they did this 4.5 here, divided by this 3, and gave 1.5. So that means they got times by 1.5. So the scale factor is 1.5. So they are similar because they got multiplied up. So this one's a little bit more trickier. So it's good that we've got this in our reference book. And now we're looking at here, what we've got the hypotenuse here. So we could test, so that's what they did. They said 16.5 over 11 gave 1.5. And then they tested this one. They said 7.5 over that 5. And they got the same number, so they know they're similar. And they wrote down, because it's a right angle, and they're similar. All right. Okay, so we want to check that these triangles are similar. So if they're similar, they've been enlarged by the same amount, which is called the scale factor. So the way you test that, so I'm going to look at the largest side on this triangle, which is 9, and the largest side on the smallest triangle is 3. So if I do 9 divided by 3, I get 3. So if I test the other side, so if I test the next biggest side, so that's 6, and the next biggest side on the smallest triangle is 2. If I do 6 divided by 2, you can see I get 3. So that's also the same number. So then we test just the last one. If we test that last side, so this is the smallest side and the smallest side. So if I do 4.5 divided by 1.5, you'd find that's 3. So you can see they were all 3. So it was all, this first triangle was enlarged by every side was enlarged by 3. So that is the scale factor. So you can say that these triangles are similar. So we say triangle ABC is similar, which is this symbol here, to triangle DEF. And why is it? Because all the sides were enlarged by the same scale factor. So you can say SSS.